Hi, Christian.
Hello.
Tell us a bit about yourself.
Yes, I live in Stuttgart, work for Novatec Consulting, and well, my experience with Java goes way back. I think 16 or 17 years ago, at the first big customer project, we did a JE migration from J2EE to Java E5. Yeah, and yeah, it was a big, very heavyweight construct that days, and by the time runtimes became smaller, frameworks became smaller. We get into Spring Boot a lot. Nowadays, we do mainly Spring Boot applications. And due to the outstanding support of Kotlin in Spring Boot, I've found my way to Spring Boot. And I read a blog post a couple of days ago by a developer who blogged about, is Kotlin a good choice for backend? And he said, I've been writing code in Java for 15 years, and I fell in love with Kotlin after 15 minutes. And well, it took a little bit more time with me. I think it took 2 or 3 days, but I definitely felt in love with Kotlin, and still I'm officially a Kotlin fanboy, you can say. Yeah.
Are you one of those people when I'm happy at Java finally gets var, you're like, man, why didn't you just come to Kotlin?
Exactly.
Okay,
good to Kotlin. Yeah. Guilty. Yes, I'm guilty.
Yeah. Is that Kotlin though? So there are two other things that you're going to talk about, right?
Sorry?
But there are two other things that...
yeah, exactly. As mentioned, I really like Spring Boot and use it still very often. Nevertheless, there are new frameworks coming up, or other frameworks, rather old frameworks, becoming new relevance. And one of them is Micronaut, which we have a close look at and already using in production. And I'm going to talk about Micronaut, let's say, as an alternative to Spring Boot, and what it does differently, in some cases, perhaps better. Yes, that's the thing. And one thing Micronaut is really favors is creating native images with the GraalVM, Oracle's new VM. We're going to have a look at that as well.
Great. Okay, so let's dive right in. I'm going to play the talk. We'll both be here to answer simple questions in chat, and anything else we'll wait for after.
Welcome to my talk today about 3 interesting Java backend ecosystem trends that are happening right now. The first one is Kotlin, the second one is Micronaut, and the third one is GraalVM. So you're going to see today how we're using Kotlin to create Micronaut apps and running them on, or creating native images together with GraalVM. So we're going to have a short introduction to Kotlin and talk a little bit more about Micronaut and what it does different than other frameworks. And in the end, we're going to see how to create a Kotlin Micronaut app and create with GraalVM a native image from that and execute it. So what is it you can expect from the session today? I try to give you an overview on the current trends going on in the Java backend ecosystem, and I'm not paid by neither JetBrains, RCI, or Oracle, so I'm independent and objective. I'm from Novatec. We are an independent consultancy. But on the other hand, it's very subjective because it's my point of view, how I see things are going on in the backend system. I try to do this really practical. So you're going to see some source code. You're going to see how these things feel. Perhaps you see this works for me, this doesn't feel right, just to give you a feeling how things work. You're going to see the 3 technologies that really fit well together, but on the other hand, they do not rely on each other. Which means you can use Kotlin completely with other frameworks like Spring or Vertex or Quarkus. You can use Micronaut with Java and Groovy as well. And of course, you can use, we'll see that later on, GraalVM with other languages. It doesn't need to be a JVM language at all. So they fit, but they do not rely on each other. On the other hand, what you won't get today is a deep dive in one of these technologies. We're doing rather a shallow dive and see how these technologies interact and how they do things together, and not one technology really deeply. And unfortunately, I have no silver bullet for you because we're talking about technologies, and normally, well, at least we are trying to solve business problems, and then technology. If technology is an answer, you probably ask the wrong questions. Technology helps you to solve business problems, but there is nothing like a silver bullet that solves all business problems. So let's start with the first technology you're going to see today, Kotlin. I always have a short phrase or claim how the technology describes itself, and Kotlin says, a modern programming language that makes developers happier. Open source forever. Okay, let's break that a little bit more down to technical stuff. Kotlin is a cross-platform, statically typed, general-purpose language with type inference. So far, so good. It was initially designed for the GraalVM, and that's what we're going to have a look at today. But it also compiles or transpiles to JavaScript, and you can create native code, Kotlin native code with it. So it's not only GraalVM, but even more. What I really like is it combines an object-oriented features together with functional programming features. It goes hand in hand, these two things, which I really like because getting there, if you're an object-oriented programmer, is not that hard. If you're a functional programmer, you feel familiar as well. It was initially developed by JetBrains, the people you probably know from IntelliJ, the IDE, or perhaps from Ktor, the framework they're doing. And they initiated the language. But meanwhile, it's survived by the Kotlin Foundation, which has members obviously from JetBrains, but also by Google. As Kotlin has its big breakthrough in the Android development, Google has a eye on the whole situation and is a big partner in the Kotlin Foundation. So I'm talking about a little bit some features I really like in Kotlin. There are way more, but some I just want to mention. Unfortunately, we don't have the time to talk extensively about all of them, but I think that's clear that within half an hour you don't learn a new programming language. But I just want to mention some features I really like. First of all, it's the null safety. So which means the null safety is built in the type system. You're going to see that later on in some code examples. You can declare types as nullable, but you have to do it explicitly. And that makes your code more precise. You don't have to do, you can't forget a null check or something like that, because your compiler says, this might be null, you better take care for it, and this will never be null, you don't have to do it. You have under expressions and inline functions as a first-class citizen, so that makes it really nice to work with them. You don't have checked exceptions. That's something that's different than in Java done. And I've read a blog post where it said checked exceptions was one of the biggest language mistakes made in Java. Well, Kotlin learned from that and said we don't do checked exceptions. It also makes your code more readable, I would say, if you don't have this catch and throw phrases. A feature I really like is the data classes. You're going to see that later on, which allows you to really, in a precise way, declare structures, model classes, where you just say, this is an entity. I don't want to do all the getter, setters, hash code equals, etc. Nice feature. Going to see that later on. String templates as well, something I really like. If you just want to, you don't have to concatenate strings or something like that, or use free marker or something like that. You can do small string templates in the language. You have extensions functions, perhaps you know that from other languages. It's possible to extend a certain class or something very locally if you want to do that with your own extensions. For example, if you have an integer and you want an integer to transform it to, let's say, German currency, you can write an extension function for the integer class and say integer dot to German currency and extend your integer value like that. Then we have coroutines, a very powerful tool for creating asynchronous applications. So it's, let's say, kind of the lightweight threading you get. I think with project Looms and Fibers in Java is somehow aims at the same thing. Coroutines is already there, is supported by different frameworks like Micronaut, obviously, Spring Boot, Vertex, some stuff like that. And it's a very lightweight way to write asynchronous applications where you can write your sequential code, and it's still asynchronous, and you don't need this callback hell you sometimes get when using something like Project Vector. Nice, powerful feature. And there's way more. If you're interested in it, go to this site. If you're a Java programmer, you feel really, it addresses you. You can see this is Java, this is how it's done in Java, this is how it's Kotlin done, this is something you don't get in Java, and this is something you don't get in Kotlin first. So visit that link. Some advantages I experience in my daily work as backend developer, because now I'm already using for more than I think almost 4 years I'm using Kotlin as backend developer. And all these modern language features, some of them I mentioned before, which you know from TypeScript, Swift, C#, languages like that, Java doesn't have. And you can't blame Java for that, because the big advantage or big thing in Java is the backward compatibility. So you can always, Java is a rather old language, 25 years old, and they still can do stuff that was 25 years old, can be run today. But that makes it hard to do real modern stuff into the language. Kotlin is a different way. They are not that old, and they say there might be breaking changes in our APIs. So that's easier for them to say, this is a new language feature, the old way won't work. Kotlin syntax is very expressive, concise, and intuitive. So you need less code, which is not only nice when you write code, but even more if you read code, because most of the time I'm reading code, doing pull requests, reviewing pull requests, reading the code I wrote 1 week ago and don't understand anymore, or reading the code my colleague wrote 5 minutes ago. So if I need to read less and it's readable, obviously that is an advantage in my daily work. So another big point is Kotlin is completely interoperable with Java. So that does not mean you have to do a big bang. Now we switch our complete code base to Kotlin and do Java no more. You just can implement one class in your Java project in Kotlin, and it really interacts well. It works seamless. Most of the time, if we start in a project introducing Kotlin, we start with the test classes. And if that is fine for the team, we do that more and more for more and more productive classes. So it's a slow evolution of your code base and not a big bang thing. And most of the all of the standard frameworks and technologies I use, I had no problem with Kotlin so far. Doesn't matter frameworks like Spring or Micronaut or Quarkus or Vertex or whatever, or JUnit, Maven, Gradle, SonarQube. So far, I never came to the situation where I said, oh damn, I want to use that tool, but we can't because at some point in time we decide to Kotlin. So far, everything worked for us. So that was in a real short matter of time how I see Kotlin, and hopefully I can encourage you to have a further look at it. But now we're coming to the second technology, and that is Micronaut. Before going to Micronaut, I have to do a short excursus about resource efficiency, because Micronaut is a lot about resource efficiency. And what do I mean with resource efficiency? It comes in 2 dimensions for me. The one is startup time. You obviously want apps to start really fast, and they should need not so much memory. Why is this important, and where is this important? Well, it's important if you run a microservice environment where you have a dynamic load scenario. So services need to spin up really fast. It's not a good idea if there are new users coming to your application and then this next instance takes about 5 minutes to start. It should start in the ideal world immediately. This is even more important if you're doing this in a containerized or Dockerized way, because in a container, you don't have that much resources. You know, you just have one CPU and limited memory, stuff like that. So resources matter. It's even more crucial if you go into serverless functions like Lambda or Google Cloud Functions, something like that, because they have this scale to zero approach where your service is gone if it's not used. And if a user comes, it needs to scale, it needs to start really fast. So the code start time is a crucial factor in serverless. This is why Java or the whole JVM approach does not seem to fit really, because you always have this overhead with the JVM and so on, and an interpreted language, and functions written in Go or Node.js somehow always start faster. So it matters. And last but not least, why does it matter? Because you pay for the resources you use in your cloud. It's a pay-as-you-use, or something called pay-as-you-go cloud billing normally. If you need much memory, you have to pay for much memory. So, well, there is memory in the cloud, you just can buy more, but if you have 10 instances of a service running, and every instance needs 1 gigabyte or 2 gigabyte, at the end of the day, you have to pay for it. So, doing it in an efficient way is something you should strive for. Okay, so this was just an excursus. Now we're going back to Micronaut, have a look what Micronaut does different. So Micronaut describes himself as a modern, JVM-based full-stack framework for building modular, easily testable microservice and service applications. So They say they're a full stack framework. Well, they're a rather new framework, but normally for everything you need as a developer, they have already modules. If you're trying to communicate asynchronous with Kafka already and do something like that, there are already adapters. If you're trying to access an SQL, NoSQL database, or if you're trying to expose your metrics via Micronaut or running it on a certain cloud provider like AWS or Google Cloud or Azure, there are connectors, the whole Netflix stack, etc. So there are numerous modules which you can already use out of the box. And they have already modules for doing this microservice 12-factor app distributed scenario, where you need service discovery, resilience patterns like circuit breakers, distributed tracing, distributed configuration management. They already have solutions for that. And they are pretty fast concerning startup and pretty low concerning memory consumption. And how do they achieve this? Well, let's go back a little bit. They see themselves as competitor to Spring Boot. And they say we're doing things different. So what Spring does is lots of the framework magic or logic relies on reflection, runtime proxies, dynamic class loading, and class path scanning. So these are very powerful tools, and lots of frameworks are built on these, but they come at a cost. And the cost is startup time is not good and memory consumption is not good because reflective code is not really optimizable for your JVM. So if you look at the history of Spring, this is okay because Spring was never intended, initially, not Spring Boot, but Spring was never intended for short-running processes, rather for long-running processes. So it was okay, but now you have this different scenario where your cloud starts up services here and here, and they start fast. So somehow this doesn't matter. Micronaut says from itself, we are the natively cloud-native framework. How do they do this? What do they different? They use ahead-of-time compilation. So they say, we don't resolve our framework logic at runtime and startup time, but at compile time. So you sacrifice your compile time increases, but your startup time and your memory consumptions is way better. So with this ahead-of-time compilation approach, you get a reflection-free, runtime proxy-free, and no dynamic class loading application, which is good for your startup time and memory consumption. So far so good, but yeah, let's say with the words of Linus Torvalds, talk is cheap, show me the code. We're going to see some code examples now, a little live demo. But first of all, I'm going to show you what we're going to do with this football manager. We're going to create a small microservice, a football manager, no to-do app or something like that. It's just a small microservice which manages footballers. Footballers have a first name, a last name, and a position they play on, like midfield, striker, goalkeeper, something like that. Now we're going to store footballers in a Postgres database, just plain old relational database. And on the other hand, we're going to expose that data via REST and JSON so that a potential service consumer, like a single page application in your browser, may read our footballers. So this is what we're going to do. So first of all, I'm going to show you something shiny new. When creating or scaffolding your Micronaut application, there comes different ways how you can do that. It's a really nice and handy CLI tool, which I really use a lot. And you can also do it. You have a wizard in IntelliJ if you want to create a new Micronaut tool. What is the new and the shiniest way is right now Micronaut launch with this. The guys and girls from you who knows start.spring.io, this is somehow the same. Yeah? I can say I want to create an application, not a serverless function right now. I want to use Java 11. This is perhaps info.novatech. And we're going to create a football manager. And we take this version. We're using Kotlin. You see, first class languages are Java, Kotlin, and Groovy. We're going to use Gradle. I recommend using Gradle when doing Micronaut. I had some issues with Maven, to be honest. Perhaps it was the combination with Kotlin, but this ahead-of-time compilation, especially with the annotation processing, somehow didn't work that seamlessly for me. So I recommend using Gradle at the time. And now you can install some features, and here you have a ton of it. Yeah, you have Cassandra, what else? Flyway, Liquibase, Mongo, Postgres, etc., etc. There's so much you perhaps don't need, or if you need it, it's good to have it, but we just use the GraalVM support. GraalVM. And that's it. Now you can generate your project and download it. Okay. And to save some time, I've already prepared this way. And here is already our pre-prepared application. If you're familiar with Spring Boot, Micronaut will feel very familiar to you from way up from the beginning. Because let's say the programming model was very inspired by Spring Boot. I'm not saying they copied a lot of it, but it was very inspired by Spring Boot. So what you're going to get is a starter class here, as you know it from Spring Boot. Yeah, this is the main method, which is executed when starting your application. And you have an application YAML where I already defined we're going to use a Postgres database. So first of all, we need a REST controller. I said we're going to expose our footballers via REST and JSON. So here I define a class, and this is, we don't need public in Kotlin, because everything I don't define as public is by default public. You only have public and private, no package protected. And you don't need brackets here, something like that. You just say, okay, this is a class football REST controller, and we annotate it with add controller. And we say, okay, this is like the resource part where everything works. And if HTTP call gets here with the HTTP verb get, execute this function. So feels Spring Bootish, and here you see this is, we don't write method, we write functions in Kotlin, and this is the concise way about it. This method just returns a string, so I don't need curly braces and return and semicolons and something. I can say this method just returns this. This is it. I don't need to define a return type. If this is clear, this is a string. Why should something else be returned? So if I run this application, let's start it up. Normally it should start in under 2 seconds, but my MacBook is pretty under pressure from the recording of my session here, so it's almost 3 seconds. And if I do a get on localhost 8080 footballers, what we're going to get, hi there, so this is it. Okay, so this is our REST controller. Now I should try to create something that accesses our Postgres database, so we're going to create a repository. And this is our repository. You just create an interface. This is Micronaut data, something that was very much inspired by Spring Data repositories and GOM, the groovy object relational mapping. So you just create an interface, and this is implements. The double point here is implements in Kotlin. Implement a framework interface, the CRUD repository, and say this handles footballers, and the primary key is type long. Yeah, and you annotate it with JDBC repository. There's also a JPA repository. Micronaut data comes in 2 flavors, JDBC and JPA, but for the moment, we just use the JDBC repository. So, and with implementing this interface, or extending this interface, we get all the method already here, save, update, by convention, the method you need. So for most of the CRUD operations you need, there's already something implemented for you. The nice thing is, this is also reflection-free and done at compile time. So everything that works, you get errors at compile time, not at runtime. So first of all, we have this, and we defined to the default methods, we already defined another function here, find by position, because position is something that only our footballer has. Okay, I forgot something. Let's have a look at our footballer. This is the entity we're going to store in the database and retrieve from the database. And here you see this is a data class. In Java, this would be just a pojo, and perhaps some of you have already used Project Lombok, where you have this annotation, add data, which generates your getters, setters, hash code, equals, copy, all the boilerplate code you need, your constructor and stuff like that. In Kotlin, you don't need Project Lombok. It's a built-in language feature that you just can say, this is a data class. I only care about these attributes here, and everything else, getters, setters, you take care of that. And you see here, I have some immutable fields, like declared here with val, first name, last name, position. If they're set at one time, they are not changed. And we have a mutable here, var, because this is generated by the database. This is mutable, and we just annotated with ID. These are just JavaX persistence annotations, you know, probably So this is a data class. We're going to save the database and retrieve from the database. Okay, going back to a repository, we just say, okay, the repository handles footballers, and we have to all the default methods or by convention method, we have one more where we say find a footballer by its position, and we hand over the position and we get back a list of footballers. This is it. This is our repository. So now we can expose this method DRS, and I created here because I'm really slow at typing. Really already created here the method, but first of all, I forgot that. I have to auto-wire my repository, and you can do that with auto-wire or inject or something like that, but I do it normally as a constructor dependency injection. I just say here my repositories. So the repository is auto-wired, and I have a get, and this one takes, let's see, a query value here, position. This can be retrieved if the request contains request parameter position. Take this, it's nullable, marked by this question mark. If I remove that, this check is not necessary, because if this has no question mark, it's not nullable. So my IDE already tells me this will never be null. So why do you this? So I say, okay, it's an optional argument, not mandatory. If it's null or empty, return everything which my repository returns. If there is a position, just call the find by position and hand over the position. We have also a get where there might be an ID, path parameter, then we just find by ID from the repository. If there is a post, we create a new footballer, so we have to extract the body, get the JSON from the body, deserialize it, create a footballer, hand it over to the repository, save it, return the newly created footballer in. And if a request with a delete reaches us, there must be an ID. This is not optional, this is mandatory. This would be optional, but we say it's mandatory. Delete by ID. So this is our application. Let's start it or restart it. As mentioned, my MacBook is in a heavy load while recording this. Normally this should work a little bit faster. But at least compiling is finished. So if I go back to my Postman, and now I can post, create a footballer by saying, okay, I do a post on localhost 8080 footballers with the first name, last name, position field, send it. I get back the created footballer with an ID. So let's create two more. This is Joshua Kimmich, also playing in the midfield. And the third one is Leroy Sané, he's a striker. So we have three, and if I do now get on localhost 8080 footballers, I get back a list of 3 footballers, 2 playing midfield, 1 playing a striker. And if I do a get on footballers /1, so I only want the one with ID 1, I only get 20 rows. And if I do, and this hopefully you can read it, this is localhost 8080 footballers position midfield. So this is what we implemented here. I now hand over a query param position, and he should go here and execute this. So send this. Okay, only get back Toni Kroos and Joshua Kimmich and not Leroy Sané, as Leroy Sané is a striker. And of course we can delete the first one. If I do a delete on localhost 8080 footballers /1, it should be deleted, and I get back all footballers. There should only be one. So this is our small microservice handling footballers. Okay, so going back to the presentation. So this starts already pretty fast, especially compared to Spring Boot. I don't want to mention the numbers here. Perhaps after my talk there's some time I give you some numbers, how fast or how different it performs than a Spring Boot, a comparable Spring Boot app. But you still have some overhead. You still need to start your JVM, and the JVM is huge. You probably don't need everything in the JVM, but there's the whole JVM. And you still have an interpreted language, and at least when coming to serverless stuff, There's always somebody who says, but that's done with Node.js way faster. And why don't you write it in Go or Rust or something like that? And so therein comes GraalVM. So what we try to do now is take a jar, which we created, and create a native image from that. So first of all, what is GraalVM? Their slogan is run programs faster anywhere. Sounds not so bad, sounds pretty promising for what we are trying to do. But we'll take a look a little bit closer what it is. GraalVM is a high-performance runtime for applications written in different languages. For example, JavaScript, Python, Ruby, but also JVM-based languages like Java, Scala, Clojure, Kotlin, and even C and C++ maybe regarded. You can put them all in there, and they can even match or speak with each other. So, but that's not the point. This polyglot point is not what we're going to do today. We're rather looking at a small part, but a very powerful part of the GraalVM, and that's the substrate VM. The substrate VM allows ahead of time compilation of your Java application into executable images, into binaries. So it takes your jar and it takes the JVM and makes a native binary out of that. How does it do that? It relies on a closed world assumption, takes a look at your code and says, this will never be needed. It eliminates everything that won't be needed. So most of the JVM you probably won't need to run your application. It throws that away and only takes what you need and compiles that to a native binary. And this is why reflection is really hard in the GraalVM. It's not impossible. If your reflective code always returns the same, it's fine for the GraalVM. But if your reflective code behaves different in runtime, it's almost not possible for the GraalVM to do that. So frameworks like Micronaut, where you get rid of reflective framework logic, match really good to the GraalVM approach. So what we're going to try now is this. Well, this is a really high-level architecture image you're going to find on their website as well, where they say, hey, you can put in different languages, and we can run them, and we can interact with different engines to run it on, like OpenJDK, or just even in an Oracle database. I just read it. I've never found a reason or why to run code in Oracle database, but it's GraalVM is by Oracle, so probably that's their business case. But the interesting thing we're going to take today is take a Java application, a Kotlin application, Kotlin micro framework, a Kotlin Micronaut service, and compile it to a native image. So, and this is done. I just take the jar I created earlier here, and you install it, and it comes with a tool which is called native image, or command, native image, and there you say, this is the jar. Take this one and create a native image from that. And this process takes, I'd say, 5 or 6 minutes, and your laptop sounds like a helicopter started. It's really, really CPU intensive. You can imagine throwing all that away. You don't need compiling it is really hard for your computer to do. So we're gonna skip that because otherwise the time would not last for that. You just have to trust me. I've done that in advance, and I can show you what I've done in my. Here you see in my directory I have already an application, a native image football manager, and I can execute that. I just say run football manager, and this thing starts up in, you see it here, 55 milliseconds. So the Micronaut jar before started in about under 2 seconds. And this starts in 55 milliseconds, the same application. And the jar needed about, I'd say, 350, 400 megabyte of RAM. And this one needs, here, football manager should be somewhere, 21 megabyte of RAM, 21.3 megabyte of RAM. So this is a completely another dimension where you get. This is where your Java application might be comparable with a C or Go application or Rust application. And of course it runs. I can show you. I can do a get on localhost 8080 and you still get back. So really nice approach to create extremely fast, extremely resource efficient applications, even in the JVM world. So just last 2 slides. I really like Kotlin, I really like Micronaut, and the GraalVM approach was really promising, but of course there are alternatives. There are other frameworks, of course there are other languages, most of you probably know, Clojure, Groovy, etc., etc. And of course there are other frameworks. Not only Micronaut has this approach, also Quarkus.io, perhaps you heard of that, has kind of the same approach, doing no reflection and targeting the GraalVM as runtime. Spring Foo is a nice project done by the Spring community where you do not so much framework magic by annotation, but in an explicit functional way. So you get rid of the overhead, which the Spring framework sometimes has. And the Spring GraalVM native is new incubator project, well, not really new, but an incubator project where they try to make Spring applications GraalVM native runnable. And there's a ton of more frameworks which really match good to the GraalVM, like Helidon, Javelin, Kato, Vertex, HTTP4K. And one more remark, if your primary goal is to create a native binary, don't forget there are both things apart from the JVM like Rust, Go, or C and C++. Perhaps that's still something you should look at. I'm a JVM dude, I stick to the JVM, but if your ultimate goal is creating native binaries, of course there are other options. And one thing I should mention, I don't know how to pronounce it correctly. It's called Project Leiden or Leiden. A pretty new project where they try to implement something that you can create static images for Java, like something we've seen on the GraalVM, but in the OpenJDK. So there is a project going on trying to bring this stuff even to the OpenJDK. So last slide, or almost last slide, for a short recap. Let me phrase it with Maslow's hammer or law of instruments. If all you have is a hammer, everything looks like a nail. And sometimes I get that feeling in the backend you have this one thing that should match everything. And that's not true. The Java backend toolbox has definitely more to offer than just one hammer. There are more languages, there are more frameworks, and there are more runtimes. Keep that in mind and don't use something for everything. And the microservice pattern, I need to emphasize that, eases changes it in that way, because you just change your language or your framework in one service. And the impact on your whole system is not that big. If it works fine, you can adapt other services. If it does not work, just roll back the one service. So I think one good point or one reason why microservices make sense is that your technical experiments just are very locally. Let's phrase it that. So I hope there was something in for you, some interesting stuff. If you want further information, I think we can discuss in a minute. Looking forward to your questions. You find me on Twitter. The code example you've seen, I pushed in my GitHub account with an explanation how to install GraalVM, etc. And take a look at that. Visit our blog. A colleague of mine is writing a blog post series about how Micronaut performs in production. And if you're interested in the whole micro frameworks, the Micronaut and Quarkus stuff, a colleague of mine and me wrote an article for the Java magazine in German, per Microframeworks with Galaxis. That's something you're interested in. Thanks, looking forward to your questions and see you in a bit.
Thank you very much for this thorough walkthrough through the technologies. I liked how you put each of them like, this is what's there now, and it's not bad, it's not horrible, it just like has certain downsides, and here's how those can be addressed. I think that's really cool because I think like you probably know that as well, right? Like it's quite common to come up with like this new technology solves everything that the other technology had as a problem, or which I don't know, which we just don't like, even if it's not a problem literally. And everything is going to be better now. And I like how you addressed that and said like, look, these are doing a good job in that respect, but this is where they have challenges or downsides and how these new ones address these. You also mentioned though that there were some additional downsides or measurements that you could not quite go into during the talk. So what would be an example of that?
Well, I think
something you can share a screen as well if we want to fiddle it, like just in case you need to show something.
Okay, I think the first things I can just mention, we can have a closer look at that afterwards. I think every technology comes at a cost. They're shiny and new and look really promising, but of course there are some drawbacks in every technology. So let me start with Kotlin. From my perspective, Kotlin has 3 big drawbacks. The one is it's definitely recommended to use IntelliJ. Yeah, the language is driven by JetBrains, and you can use it with Eclipse or Visual Studio. But yeah, if you want to use the shiny new features, you have to use IntelliJ. Second thing is going from Java to Kotlin is pretty easy. You just paste your code in IntelliJ, and it transforms it to Kotlin code, which is very good. The other way around, going back to Java, is rather tedious. That's not so nice. You have to do more steps to get your Kotlin code back again to Java code. So it's a little bit a one-way direction. Also, as a developer, I have to say, once switch to Kotlin, going back to Java sometimes feels a little bit painful, to be honest. Yeah,
yeah,
so
I can see that. Or like if you, for example, I've done a lot of just very small things, right? I've done a lot of JavaScript, like the newest version, just Node.js on my machine, no semicolons, all the nice, all the inline functions, all of that. And then occasionally I have to go back to my actual JavaScript code that should run into a browser, like which is like 5 years old. I'm like, oh man, this feels so horrible. Like I have to put all the semicolons, like all of that. And it's like without transpiling, and that's a different can of worms. But yeah, so that's actually, it feels like it's the same thing, like going back from Java 11 to now going back to 8.
Exactly.
Like,
you used it, and it's not horrible, but you feel, why do I need to have write new in front of every constructor? You can do that, but sometimes you feel, of course, it's a new object. And the third thing is your build time increases as your compile time increases with Kotlin. This is normally when you're doing incremental builds, it's not that big, but when doing clean builds, I think it increases about 10 or 15% from a guessing. So that's something you should keep in mind.
Okay.
What else? Well, Micronaut also has some drawbacks, to be honest. It's a rather new framework. It's only there for about 2 years. I think it was first mentioned in May 2018, something like that. So it has not that big ecosystem like Spring and Spring Boot has, of course. You can use a lot of Spring components like the config server or Eureka and stuff like that. But of course, they're not that feature complete as Spring is. And from developer perspective, some things change when switching from Spring Boot to Micronaut because of this annotation processing and ahead of time compilation. For example, testing and mocking beans in testing is a little bit different because it cannot be done at startup time. Your compiled code need to be mocked. So it's different. It's not better or worse. It's just different. So coming from a Spring Boot testing background, it sometimes feels a little bit unusual. Yeah, but I think that's just to get used to it.
Yeah. So I think there have not been any questions in chat actually. So that's a bit surprising. I don't know. Do I have anything else? Like the downside now is we discussed this on a closed beta, like 3 weeks ago. So I think I asked all my questions that I had back then already. So without further ado, if there are not many questions, we can just leave it as it is. Thank you very much for your talk. I hope you stick around the conference and maybe find some other people to talk to. And I'm sure looking forward to the future. You have been doing this for how long now? With Micronaut and there's actually a question. But with Micronaut and Kotlin, you've been using it for a couple of years, you said, right?
Yes.
So I was going to say, like, we can meet again in a few years to see how well it went. But you actually do know this is already from practice, right? This is not like when I talk about Kotlin when it's all just pie in the sky. You do know what you talk about. You did this in practice already.
Yes, of course.
Yeah. I mean, maybe, but that's, I think it's also because I was going to say, like, we can meet again in a couple of years and you can tell us how it went. Okay, so look, I'll do the following now because I have to back to the main stage. If that's okay with you, Christian, I'm going to leave you here with these nice people in chat.
Yes, of course.
Just move myself from the chat. From the image. And as soon as you're done, and if there are no more questions, or when we come up against the next full hour, you just pop out, close your browser window, and everything is perfect.
Okay. Thanks.
So, Jakob, the questions. I'll leave you with Christian here. Bye.
Yeah. Bye-bye. So your question is, what's the life cycle of Micronaut data entities? How do transactions work? Anything like edge transactional? That depends a little bit. As mentioned, Micronaut data comes in 2 flavors. The one is the JPA flavor, and there you have the transactional. Yeah, this is not what you've seen in the example, but of course there you can define the JPA style transactional and do, let's say, more database connection or more database processes in one transaction. The JDBC approach I've shown so far is rather one operation is one transaction. So yeah, I hope this answers your question. Micronaut data is pretty new, so it's worth having a look at. And so far, it's only for SQL databases. They're working on some MongoDB adapters, etc., but that will take some time more. I've put this whole example in my GitHub account. You can check it out, and it should be sufficient enough to run it on your machine to build the app and how to install the GraalVM and run it natively on the GraalVM. So perhaps that is a good approach. Have a look at it. Yeah, and come back to Micronaut data. First, it's a little bit confusing coming here because this difference between JDBC and JPA. One good approach to differentiate between them is if you do something like one entity matches to one table, JPA is a good approach. If you say, I want to create my own DTOs and collect from different tables, the JDBC approach is perhaps better, also as it's more lightweight and suits more the whole, let's say, serverless, get your memory consumption pretty low approach. Okay, if there are no further questions, I just leave it for the minute and I'll be around. Just get in contact with me. I have also some examples what is different in testing with Micronaut. If you're interested in that, I hang around, just ping me. See you there. Bye-bye.